So the ratio of consecutive terms just means that we're going to be finding the ratio between tk and tk plus 1. Yeah? So the ratio of that term and the consecutive term. So let's consider that in the expansion of a plus b to the power of n. So the ratio of that will be tk plus 1 on tk, right? So let's firstly write out the general terms. So you know the general term for tk plus 1 is quite simple. So that's nck, a to the power of n minus k, b to the power of k. Now for the term tk, right, that's actually just one less than that, which means instead of k, we have k minus 1. So we have n minus k minus 1, and this becomes k minus 1 there. So then what we do is we need to somehow simplify that. And before we simplify, the first thing we need to do is express our combination in terms of factorial. So remember, our combination nck is actually expressed as n factorial on n minus k factorial times k factorial, okay? Now this here, nck minus 1, becomes n factorial, but that k there, essentially you have n minus k minus 1. So can you see how that's how it becomes n minus k, but the minus times the minus makes it plus 1 there, yeah? Then that's how we get n minus k plus 1 factorial, and this is just k minus 1 factorial from there, all right? And the other little step we've done is we've just broken off that bit to there, and this n minus k minus 1 I've also made into n minus k plus 1. And now I want to consider how we do cross things out there. So essentially we have n factorial on n minus k factorial divided by that, which is also the same as multiplied by that whole thing flipped around, right? So multiplied by n factorial with n minus k plus 1 factorial k minus 1 factorial there. So then you can see that this and this cancel out, and that just goes on top of that, right? And that's how you get n minus k plus 1 factorial, k minus 1 factorial, yeah, on n minus k factorial there, okay? Multiplied by b on a. So how do we get that? Well, we have a look here, and you can see that b to the power of k minus 1, that's 1 less than k, right? Because it's k minus 1, that makes sense. So that cancels out with that, so it just leaves you b on top. Whereas here, n minus k is going to be 1 less than n minus k plus 1. So therefore that whole thing cancels out and cancels out that index until it becomes 1. So that's why you get b, which is left over there, on a, which is left over there. Can you see that? Good. So that's how you get b on a there. So now, once we've gotten to that step, I want you to consider how we cancel down factorials. So do you guys remember how we cancel down factorials? Yeah, because a factorial just means that it's going to be, when we have 9 factorial, that just equals to 9 times 8 times 7, etc. So that's the same as 9 times 8 factorial, right? So remember that concept? So in that same way, what I'm doing here is, instead of having n minus k plus 1 factorial, I have n minus k plus 1, and then I have 1 less than that, which is just n minus k factorial. So the same idea as 9 times 8 factorial, yeah, just 1 less. Similarly, on the bottom here, instead of k factorial, I've made it k times 1 less than that, which is k minus 1 factorial. Yeah, can you see that? So I've changed this into that, and I've also changed that k factorial into this here. So in that way, I'm able to cancel out this n minus k factorial, that n minus k factorial, this k minus 1 factorial with that k minus 1 factorial, yeah? And what's left over now is going to be n minus k plus 1 on k times b on a, all right? So therefore the ratio of your consecutive terms, so any ratio at all within your expansion of that, is going to be n minus k plus 1 on k times b on a. So now what we're going to do is use some questions to work out the ratio, but I want to use this whole thing here because I want you to understand how we do get to this equation over here, which we will memorize later. But before we go on, so just a little summary here. What you need to do after writing this out is make it into factorial form, yeah? And then remember how we cancel out factorials by expanding it like this, right? And then you just simplify that and you get that as your final answer. So I want to move on to question 1 now. And here I want you to write the tk plus 1, so essentially just a general term of 2x plus 3y to the power of 10, right? That's quite simple. That's just going to be 10 ck. That'll be 2x to the power of 10 minus k and 3y to the power of k. And now write the term tk for this same expansion. So remember, the only difference here is that that's 1 less than that. So instead of k, we just have k minus 1. So this becomes 10c k minus 1, and that becomes k minus 1, k minus 1. Let's just simplify that a little. And that 10 minus 1, so that becomes 11. 11 minus k essentially. All right, so now we worked out the general term as well as tk. Let's find the ratio of the term k plus 1 and tk here. So remember how we do that is we put tk plus 1 on tk, and this is what we just worked out. And the first step was, exactly, we got to put it into factorial form, right? So factorial form for that is going to look like 10 factorial, yep, on 10 minus k factorial times k factorial. Whereas for this bottom one here, it'll be 10 factorial. And instead of having, well, we have 10 minus k minus 1, that whole thing factorial essentially, right? But because we worked out before, that's just 10 plus 1. So we have 11 minus k factorial, and this is just k minus 1 factorial there. Yeah, that's how we made the jump from that to that, multiplied by this over here. Now we need to cancel and flip. So remember how, because it's being divided by that, essentially it's being multiplied by that. Remember how we flipped it? So then we could cancel this and this. And because we were flipping it like that, that meant that became the numerator and that was the denominator. Yeah, remember how we did that in the example? So that becomes that on that. Now working with this, k minus 1 is 1 less than k, so that whole thing cancels. That k just becomes 1, right? Whereas 11 minus k is going to be 1 bigger than 10 minus k. So that whole thing cancels and that becomes 1 there. So that's why you get 3 on 2, all right? Now, this is our difficult part, which is where we need to simplify this. And how we do that is by using our factorial expansions. So the easy thing to do here is make this k into k times k minus 1 factorial. Yeah, using that same concept of 9 factorial equals to 9 times 8 factorial. Okay, so just 1 less than that. And up here, 1 less than 11 is just 10, right? So that's 10 minus k factorial times that is exactly the same as 11 minus k factorial. And now we can just find out things to cancel down. So that cancels with that, and this cancels with this, and it's going to leave you with 11 minus k on k times 3 on 2, right? And you can just leave it like that without expanding it because that follows that general formula that I'll show you later. All right, so you can see here how we've used that same routine of making it into factorial form. expanding the factorials over here so we can cancel down and making it into that form which we just saw before. All right, so let's do one more practice with this. So in question 2, so firstly write down tk plus 1. So that's just going to be, because it's 8 up here, it's going to be, yep, very easy, 8ck, 3a to the power of 8 minus k. Should be very familiar with this by now, minus b to the power of k. And now remember, for the term tk, all it is that that's 1 less than that. So instead of k, we have k minus 1, yeah? Instead of 8 minus k, you have 8 minus k minus 1. This is k minus 1 as well. And then we simplified that a little bit. So 8 minus 1, 8 plus 1. So that becomes 9 minus k. Easy, all right? We've got those 2 terms written out. So when we find the ratio, we just write it like that, and then we got to put it into the factorial form, okay? So why don't you guys do that first so I can test if you've been remembering how to put that into factorial form? Yep, have you done that? So it should look like this. This is 8 factorial, 8 minus k factorial, and down here the only difference is this is k minus 1, and because you have 8 minus k minus 1, that becomes a plus 1, so that becomes 9 minus k factorial, yeah? Times, that will be minus 1 on 3, and in this case, you see that you just have, because it's just minus 1 there, here, what we do is you simplify exactly like we did before, which is that is 1 less than that, so that stays. Whereas over here, because that is 1 more than that cancels and that stays, right? So that's how you get minus 1 on 3. But be really careful with your negatives. Make sure you're keeping that negative 1 there. Now, we cancel. So that cancels with that. And because we're flipping it, remember? So that goes on top, okay? So that's how we get to that step there. And now you guys remember you need to expand your factorials, all right? So we need to cancel. So we've got to somehow make this look like k minus 1 factorial and make that look like 8 minus k factorial, all right? So give that a go first. So how are you guys going? Yep, good. So you're meant to make this into k minus 1 factorial, and you expand this into 9 minus k. 1 less is 8 minus k factorial. Yeah, and once you've done that, you can cancel those out and that out. So you get left with 9 minus k on k times minus 1 on 3 there. So once you have that, you've found the ratio for this expansion there, which we're going to use later to find the greatest coefficient. Okay, and just with this one, because we have that negative 1 there, which I told you to be careful of, it's best to get rid of that negative completely, and the best way to do that is consider it as negative 1 on 3, yeah? So it's actually negative 1 times that, right? So you're just going to multiply that negative 1 by everything over here. So this becomes k minus 9, right, on top, and that's why you have k minus 9 on k, and we've gotten rid of that negative 1, so that just becomes 1 on 3 there.